Hey guys, welcome back to the RCA RR-359B pre-war field test television restoration project. Last time I took a deep dive into the upper chassis. This time we're going to do the lower chassis, which is the power supply. Now, unlike the top, which had seen modifications, we're missing a tuner, it's kind of a mess, this is a lot closer to stock. Let's take a little tour of the chassis, which is also immensely heavy. I was warned about this before I even picked the setup, and they were not kidding. I'd say it weighs about 100 pounds. So not the easiest thing to lug around. Reason for that, we'll get to in a moment, but basically there's a lot of iron in this thing. Now, you may have heard these pre-war sets referred to as widowmakers. What does that mean? It means the high voltage supply is somewhat lethal compared to later sets. The basic reason being it can supply more current. It's not that, it's the main power transformer for the high voltage is this guy. Puts out 6,000 volts at a milliamp or thereabouts, looks like a neon sign transformer. Gets rectified, gets filtered, and goes to the set. Now, you have about that much voltage in a later black and white set, but those can't deliver as much current. So I don't think it's so much that it's a flyback versus a high voltage oscillator like you'd see an electrostatic set versus a 60 hertz transformer like this. I think it's more the current that they can deliver. Anyways, definitely want to exercise some caution when you work on a set like this. Now, I noticed something a little odd when I picked this set up and took a brief look at it, because there was this piece of steel wire here going through a hole and twisted around. Goes up to this transformer. And I noted that this lead coming out the side of the transformer smashed into this capacitor. It's kind of bent to the side, and this just all looked a little odd. Well, it turns out that this is not the original high voltage power transformer. I was told it looks like it's from a TRK-12, which is a production pre-war set that came out a few years later. They have it attached by a couple screws here. I think they added this plate here to mount it. And on the other side there's nothing except that piece of wire, so this whole thing can move. It's not great, but one thing that is a little bit of a plus is that I believe this can put out a little bit more high voltage, about 7,500, which the CRT should be able to handle, so it should be a little bit brighter. We'll see. So high voltage transformer running right off 120 volts AC or thereabouts. The output of it goes into this box where we have two high voltage rectifier tubes, an 878 and an 879. The larger one is the main second anode high voltage supply, as I said, about 6,000 volts. And a smaller one is for the focus, which is about 1.25 kilovolts. There is a little bit of something that might save you here, which there are some resistors to limit the current in line with the input. So the AC coming in the top, DC coming out the bottom. Then that goes over to these guys, which are some high voltage filter caps. There's two caps in each one of these. But what's crazy, and accounts for some of the weight, is what else is in here. I believe it's this box. There's a filter choke for the high voltage supply. I'm sure you're all familiar with filter chokes for the B plus supply. This has filter chokes for the high voltage supply. And they're very high resistance, like 15 kilo ohms. So I expect there are many turns of wire, rather fine wire. So I really hope they're good. So yeah, those are the wires coming through here. So there's a filter choke. So it forms a pie filter. We have a cap, and a filter choke, and then a cap, and then it goes off to the set. I'll show you the schematic in a bit. These guys got a whole bunch of dogwood and resistors on a phenolic board, which unfortunately cracked. Perhaps super glue works pretty well on this, so I can perhaps glue that up on this edge, and the other edge is on a ceramic standoff, which I think is original, and that's to keep it from these guys. All these wires have high voltage on them. You can see that it's kind of ugly spliced here from the replacement transformer. Oh, this is actually rubber. on this side and cloth covered on the other end. This is the kind of stuff I'm considering replacing with modern high voltage wire, especially where it's spliced together with some old electrical tape around it. I really don't want any of this stuff to arc and cause any damage. But anyway, so what are these about? Bleeder resistor network, very similar to an electrostatic set. If you look on the schematic, I think they show a 6 mega ohm resistor, but it's actually made up of a whole bunch of resistors. So all these are just in series. Because if you put 6,000 volts across one of these dog bones, it would just arc. It couldn't handle that much voltage. These are good for maybe 500 volts, something like that. So there's 3 or 4 in series for the focus, and then 6 or 8 or something like that in series for the main high voltage supply. They're there to drain it off. If you turn the set off, this will discharge these caps. Below that, it gets a lot more conventional. We've got 2 full wave rectifier tubes in parallel, I do believe, and some electrolytics here and a couple over here, can dome. That forms the main B plus supply and filter for it, and additionally some big filter chokes on that too. So let me spin this around and I'll show you why it's so heavy. It's heavy basically because of the era when this was made. This was produced in 36, I presume designed in 35. Back then, electrolytic capacitors were still a fairly new thing and generally only available in smaller values. And I get the imagine design engineers back then might have not trusted them so much, or it was still kind of a new thing, whereas they've been using big iron power transformers, filter chokes, going back into the 20s. So most of the filtering is done by filter chokes. This, I believe, is the main power transformer, and then these 2 are filter chokes, and that's filter choke for the high voltage supply. So and we just have these 4 electrolytics, and they're not that large value. Maybe like 20, 30, 40 microfarad. They're just individual caps. They're not twist locks with, say, 4 caps inside. Because like I said, this is early days, and they couldn't make small, high-capacity electrolytic caps. So we just have 4 of them. Hence, this thing is really heavy. There's also a couple electrolytic caps inside of that box there. We can open that up and restuff it. Also got gnawed on a little bit, unfortunately, so you can kind of peek inside there a little bit. Now this stands out. I didn't notice this when I picked it up. As soon as I posted a photo, somebody brought my attention to it. They're like, hey, that's not original. Yeah, this open frame transformer was added. I do not know for what yet. When I saw that octal tube had been added, my first thought is, oh, that's the filament supply for that octal tube or something like that. But no, that's a 117. It's running right off the AC line. I don't know what that's for. Obviously, it's not that large, so it's not replacing the main power transformer. It's not replacing the high voltage transformer. We'll have to trace it out. My hope is that it was added to power whatever the mystery aftermarket tuner that was added to the set. The set something to do with that. So if that tuner's gone, it's entirely possible I can remove this and I don't need this at all. I can get this more stock looking. This is what I proposed working on first. I mean, after all, if you don't have a power supply, you can't turn the set on. It's not going to do anything. I will never be able to source an original high voltage transformer, or it's extraordinarily unlikely. So I'll go with this. I'll try to clean this up a little bit. It sure seems like this piece, I don't know if it's slid down or what, but it's kind of fused in place. But it sure seems like it should be up here to provide a little cushioning around this high voltage lead so it's not going right up against the metal there. I need to restuff these or put new high voltage caps somewhere. I suppose I could leave these and mount them underneath, or I could try to unmount these and restuff them. I'm not crazy about how this one's getting mashed, but I also don't want to mess with this stuff. So, so be it. If it's pushing up against it and it's bent over the side a little bit, it's not the end of the world. Yes, the main challenge on this will be to restuff these electrolytics. I'm pretty sure these two are original. These two are not, or maybe one of them is, but this has got to be a replacement. But it's had far less done to it than the other chassis. Under here, go over the wiring, make sure it's up to snuff. Really, the only wiring that I've seen that concerns me is some of the spliced in high voltage stuff. Dog bones. So we're going to have to deal with a lot of dog bones in this set, and frayed wiring. Honestly, I think that's where most of my work is going to be. The electrolytics, I realized on the upper chassis, if you go back and watch the previous video, if you haven't seen it already, there's 8 or 10 sprig atom and other type of more modern electrolytics that were tacked in all around it, and I was surmising that, hey, maybe it was to replace some caps down on this lower chassis, which is super heavy, and they put them into the top chassis instead of doing the bottom. I didn't realize there's a box on top of the upper chassis that has something like 6 electrolytic caps inside of it. So I'm pretty sure all those caps that were added on the upper chassis are to bypass those, not anything to do with this chassis. So I think we're going to need to take care of these 4 caps, which are just like the ones you'd see in a radio from the same era, and rebuild this box cap up here. And we'll chuck that can dome. We need to redo this board. Oh, anyways, back to what I was saying, about dog bones and wiring. I suspect an awful lot of these dog bone resistors are going to be out of spec. They're pretty visible, they're rather colorful, they're rather nice looking when they're not all discolored like this. They don't make anything like this these days. So I'll have to fabricate some. I did that years ago on a Philco radio where I took modern they're metal oxide resistors, and I molded them. I actually made molds. I took some original dog bones and made molds out of them, and I put 2-part epoxy putty over the modern resistor, and I put into the mold, and after it's set up, I painted them, and they look quite nice. So I may do that, or I've seen some other techniques, but I'm going to need to fabricate a bunch of these. And then the wiring, I'll get cloth wiring or something that looks similar to the rubber wiring as needed. Most of the electrolytics that I've seen are in boxes. Those are easy to restuff. And then these 4 guys. I could probably just tack new electrolytics underneath the chassis and not do anything with these. But even if I do cut these open, these are pretty easy to do. It's just a single electrolytic in each one of these. And they're going to be small, 10, 20, 40 microfarad, just a single cap in there. So that's why I say there's plenty of room under here to mount them as well. And this, I believe, is the power cord. It does have a fuse. You can set it to either 110 or 120 volt primary operation. There's probably used to be a plate over this one that I'm missing. And there used to be a cover over all these lugs that I'm also missing. If you recall, in the upper chassis there are some cables that come down that have a bunch of spade terminals at the end of them, and this is where they all go in. And then finally, there's an empty socket, and that's where I was thinking I was missing a tube, possibly the high voltage rectifier, but no. There's a cable going to the upper chassis that terminates in a tube type plug, and that plugs into that. So some of the power comes out the terminal strip, some of it comes out that plug right there. These are 2 high voltage rectifiers, which I think are 5Z3s. We've got some corrosion. I haven't decided how far I want to go on this. These are built, this is built in typical RCA construction technique of the era. If you go way back and watch some of my videos on doing an RCA radial TV or my Westinghouse WR8, I pried up the tabs and took the transformers out, particularly the WR8. I took them all out and I repainted them. So it can be done, and I can remove this corrosion. I just don't know that I want to, at least not yet. These guys, it's pretty thick metal tabs, but you can get in there with a little chisel and a hammer and start bending them up. And try not to introduce metal fatigue so that they break off, and then put them back down. But on the other one that I did, it had been painted originally, and it was painted brown. This, I don't think any of this has been painted. That's why I'm a little about taking it all apart, just to clean the metal. This is the only one that's corroded, I do believe. And we do have a tag on here. RCA television power unit RS-53. Serial number 001034. You know, I don't think that matches my upper chassis, but I've been told it's not at all unusual for the cabinet and the two chassis all to have different serial numbers. Actually, I was mistaken. This is not the power cord. I'm not sure what that is. This is the power cord. That probably goes to an AC interlock system. So, yes, I could plug this in right now, but no, I'm not going to. I think that's going to be it. I'll give you a look at the schematic, and then we'll call this a wrap. Oh yeah, so I'll definitely show you the schematic, because there's one interesting thing about this set I alluded to in the previous video, the focus control. So to vary the focus, you need to vary the high voltage on the focus element, which is a bit over a kilovolt. Similar to what you'd see like in a color TV, like by CTC5, there's a separate little high voltage rectifier tube sticking out at an odd angle on the flyback. And for that, there is a high voltage pot mounted right nearby, and when you are adjusting, I think it has a plastic shaft or something to protect you from getting shocked. Well, on this set, they could have done that too. They could have made up a high voltage potentiometer and run it up to the front of the cabinet, but they didn't want anybody to get shocked. And I imagine they didn't have the materials back then that could make a really reliable high voltage potentiometer. So what there is a big old rheostat, like a 25 watt rheostat. That is varying the voltage to the primary of the little transformer for the focus, which is one of these guys. I think it's this box. So they have that rheostat, I believe, is in series with the primary on that high voltage transformer. So as you vary that control, it alters the primary, like a variac, and it's going to vary the high voltage output. However, you also need a filament supply for the high voltage rectifier tube. Now, if they powered that tube from the same transformer, as you varied that rheostat, you'd also be varying the filament voltage on the rectifier, which is not desirable. So both these tubes, high voltage tubes, filaments are powered off of this transformer. And the focus voltage transformer is just for a variable high voltage output. Alright, let's look at some service info. All of this has come courtesy of Daryl Hawk. He's been mentoring me, I guess you could say, on this set. He knows quite a bit about them. He owns a couple, and he has some excellent service info, including some very high-res photos. So here is what this thing would have looked like when it was brand spanking new. And that's what I base a lot of what I just said to you on. So that's how I know I'm missing the cover for this, plus Daryl filled me in that I was. And you can see that some of the parts look a little different, like there's no high voltage lead coming out of this transformer. The leads are all down below. And I can see what the original caps look like. Here's the underside. So again, I know exactly how this looked the day it was made. Wooden blocks. When I unpacked this set, I found one of these, and I was speculating what it might have been for. Now I know it's for this, and I'm missing one, so I'll have to fabricate a couple. Typical RCA construction, as I mentioned, those radiola radios I've worked on. Not only had this bent over tab to mount things, but they also had wooden blocks in them, so I'm familiar with that. technique. Alright, and that's what my upper chassis looked like when it was brand spanking new too. And when I say mine, I literally mean mine. As Daryl pointed out, this is my serial number. These photos are literally, I don't know about the power supply, but this upper chassis, this is my chassis as it was made when it was originally a 9-inch. So how cool a resource is that? The service binder literally has my chassis in it. Alright, let's get to some schematics. So, power supply. Yeah, okay, here we go. So there's the main power transformer. And our two 5Z3s. So we've got a few secondary windings here. One is the power of the 5Z3s. One is going to be your secondary center tapped full wave rectifier for your B+, which is around 285 volts, I think. Then we've got a couple, let's say 6.4, really 6.3 with load. That's to power the tubes, and most of which are 6.3 volt tubes, like these 6A6s, 6C6. But we do have some 2.5 volt tubes, including the CRT. So that's what these two guys are for. High voltage is over here. So here's where I mentioned about there is a transformer just for the focus, and then this is for the main high voltage. And both of these rectifier tubes, filaments, are coming off of this guy. And here are those filter chokes I mentioned. So let's look at the focus. So we have right off the rectifier, we got a 0.05 microfarad high voltage cap, and then a filter choke of 14,600 ohms, and then another cap. And there's a 2 meg bleeder to drain it off. The main high voltage is very similar, but 0.03 microfarad, and same resistance here on the filter choke. And then here's the bleeder resistors. So that's what I mentioned, where it says 6 meg here. You think, oh, it's a 1 6 meg resistor, but no. I think it's 6 1 meg resistors in series when you actually look at it. Now, primary on this guy. We follow this line over and around and around and around. There's that focus control. It's a 200 ohm rheostat that varies the power going to a transformer, and that's how they vary the focus voltage. And there's 3 interlocks around the set. I think there's one on the back, there's one on the base of the CRT, and there's one somewhere else. Then there's the AC power switch. So there's 4 places the AC power is broken into this set to safeguard the end user if they go poking around inside, to make sure there's no power getting to anything. So yes, I do have a schematic now. We'll go over this more in detail as we start diving into it, but let's briefly show you a little bit of stuff. So that upper chassis where I saw those candom resistors that are just a mess and all these other parts were tacked in place, power resistors, other caps, here it is on the schematic. You can even see back then they were making alterations to it, so I need to be pretty careful when I start working on this that I wire things up correctly for exactly the revision I have and the changes that have been made. So I don't necessarily want to go back to how this was when it was originally made. I need to kind of pick the point in time I want to restore this to. And this is the tuner that I'm missing. So I have some idea what I'm trying to do at this point. Alright, that is going to be it for now. Thanks for watching. My next major step is to go to the Early Television Museum in Hilliard, Ohio sometime in the next several months and take a look at their set and photograph it, especially the tuner, and take some measurements and poke around with it. That's it for now. Thanks for watching.